So hello viewers and welcome back to another video on Web-NS3. So if you have watched my last video where we have talked about Web-NS3 and how we can use the parameter sweep inside Web-NS3. So there we had made a request to Web-NS3 team that we need an ability to compare the results from the various runs. So let's say we are running for we are running the same file for multiple parameters. So let's say we need an ability to compare all those results in just one graph. So now they have added in this folder which is called combine, and inside this combine folder the file which is there, it contains all the it contains combined result from all the run. And now let's say if we want to visualize all the results inside one graph. So these are the readings for TCP congestion window change for various TCP congestion control algorithm. So we can just click on show graph, and if you see this cool looking graph, we can observe for all the TCP variants that are available for us to simulate in NS3. So how I have created this visualization and what is the script that I am using, we'll see all this stuff in today's video. So without wasting much time, let's get started. So before we actually start with the practical stuff, I must mention this docs page for the TCP models. So TCP models, this page lists basically all the TCP variants or the congestion control algorithm that are available for us to simulate inside NS3. So if you see congestion control algorithm section, it contains new Reno cubic. So cubic is very important TCP congestion control algorithm because that is the most used congestion control algorithm, and that is being used inside Linux, Mac OS and Microsoft Windows. So pretty much all the OS that you might be using or you might have been familiar with. And then there are other variants like Linux Reno and high speed, high blah, Westwood, Vegas and Scalabla and Veno and blah blah blah. All those variants you can see, and you can understand then how each algorithm is using the equation or how the next congestion window is being calculated. That all the things are mentioned over here. So let's now get to the scripting stuff. So all those TCP variants that we have seen for the on the models page, that all you can see inside. Let's say if you have for me I have NS 3.44. So if you go inside the from the root folder of NS3, you can go inside the source. You can go in from the source inside internet, inside model, you will find all those stuff. So if you see over here, you will have all the TCP variants. So TCP STCP, then TCP hybla, then TCP cubic, all those stuff you can see and observe here, that how the code is written for those. And you can also modify for your use cases, and you can experiment with those modifications. So what we are going to do is, so under the examples and tutorials folder, example/tutorials folder, we have something called fifth.cc file. So if you see this file, this is the same file that we were using in the past videos. So this file has this thing called set protocol set default config.set default, and we are setting the TCP algorithm that we want to use. So make sure to add what we are going to do basically is, we can just change this algorithm for whatever TCP congestion control algorithm that we want, and we can run this script. So for that, what we can do is we can just add a command line argument. So that's what we have did inside this TCP base combine file. So what we have created is, we have created an array which contains the list of all the TCP variants that are available for us to simulate inside NS3, and we have added an command line argument. So using this, what we are going to do is, inside the Web-NS3 we are going to do the parameter sweep for this algo parameter, and that will be starting from 0th index, and it will go up to 6th in index, and for each run we will step the algo variable this algo parameter with 1. So we will have the simulation for TCP Reno, then cubic, then Linux Reno, and in order from 0 to 16th index. So that's what we are going to see. So now we are inside Web-NS3, and if you see, I have a simulation named Great TCP Simulation. So if I go to edit, so that is the same script that what we have seen in the my virtual machine. So that same script I have copied over here, and inside the number of runs we'll keep it 1. So make sure to keep the number of runs 1, because otherwise that combined folder that we were seeing, we can't see that folder. So make sure to add number of runs is equals to 1 always, and then inside the parameter sweep, so here if you see, we are using the data parameter to set the client data rate. So we'll start that value with 3. We will end that value with 3, and we will step this variable with 0. So each time the client data rate will be 3 Mbps. And now algo parameter, we will start the variable with 0. So the first run will happen for TCP new reno. We will end this parameter with 16. So the last run will happen for TCP BBR, and we will step this variable for each run by 1. So that is the normal parameter sweep configuration. We can hit this run simulation button. So once this script is simulated, we will have results. So if the simulation is completed successfully, you will have all this output of run. So basically you can explore individual results. So you see, this is the TCP Westwood algorithm simulation for TCP Westwood, and we can choose the axis. And yeah, in the last video we didn't had this first line, so that makes ambiguity in understanding what is this, what are these readings for. So it's good to add this header line for your reading, so you can have an easy clarity that what are these readings for. So we'll make a graph for time versus new congestion window, and we'll group by this algorithm. So this is the graph for TCP Westwood. Now what we can do is, we have this combined folder and this x.cwnd file which contains the results of all the algorithms, all the runs that we have it over here. So if you see, this has 6731 rows, and now again we can make an time versus new congestion window graph, and we can group this by algorithm. And if we click on show graph, so these are the cool graphs. See, these are the graph that we can see for all the TCP variants. And for more clear visibility, if we just click on this logarithmic y-axis, so this will be more visibly good. So now we can compare any two TCP variants according to our use cases. And let's say we want to keep the TCP cubic, and we want to compare the TCP cubic and let's say TCP Linux. So if you see, this is the graph for TCP Linux Reno, and this is the graph for TCP cubic. So we can also add another, let's say we can add TCP big. So this is the graph for TCP big. So that's how you can make your conclusion out of this cool looking graph. And this is very useful because if you have multiple runs for the same script, and if you have this graph with combined results, and you can compare any two TCP algorithms, so that will be very useful to you. So I hope you have got the idea about how we can use this feature, which has an ability to combinedly show all the results, and we can make we can show a graph, we can show conclusion, we can make our conclusion out of all those combined results. So that's it for today's video. I hope you have got the idea about how we can use this new feature of Web-NS3. If subscribe to our channel, if you are new to this channel, and if you like this video, so you can also make a comment regarding any feature, any new feature that you might want to be added into Web-NS3. I can pass those all those suggestions to Network Simulations LLC. So that's it for this video. We'll meet in the next one. Till then, keep learning and keep exploring.